Hello Math 20-1s. Today we're going to do some solving quadratic equations by graphing. So just remember that the quadratic equations are equations in the form ax squared plus bx plus c equals 0. A, b, and c are real numbers. Here's the key stuff. The graph of a quadratic function y equals ax squared plus bx plus c represents all the ordered pairs x and y that satisfy this function. When solving a quadratic equation, ax squared plus bx plus c equals 0, we're interested only in the values of x that make the expression equal to 0. So all that's changed from the equation to the function. All right. Note that the solutions of the quadratic equation are known as the zeros of the function. The real zeros are the x-intercepts of the parabola. So that's what we're looking for. We're looking for the x-intercepts of the graph of the corresponding function. All right, let's use a graphing calculator to solve by graphing. Okay, so if we're asked to solve this equation, x squared minus 6x plus 8 equals 0, we can solve it by graphing the function y equals x squared minus 6x plus 8. All right, and then we're going to look for the x-intercepts of this function. They're going to be the solutions to this equation. So here are the steps. You've got them in your notes. We're going to go through them right now. So on your graphing calculator, so we get your graphing calculator out, and we're going to go to the y equals screen, and we're going to type in the equation that they asked us to solve. So that equation is y equals x squared minus 6x plus 8. So x squared minus 6x plus 8. Step 2 says we should go zoom 6 on our standard viewing window. So you go zoom. You scroll down to the number 6, we can just hit the number 6 to get our standard viewing window, which is a 10 by 10 window. It graphs the parabola, and we're looking for the x-intercepts. So we're going to find those by going second function, calculate, and we get this menu. And we're going to go down to the number 2, 0, and follow the on-screen prompts. They would now want us to find the left boundary of the first x-intercept. So I'm going to maybe move my cursor to there and press enter. I'm now going to get right of the x-intercept. So I'm now right of my first x-intercept and press enter. And you notice I've got two boundaries up here. It's going to bound where I'm looking for my 0. If I make a guess, I can go back and try and make a guess there, press enter. And so the first x-intercept is at 2. Let's find the next x-intercept. Go second calculate, also 0. Scroll to the left of that second x-intercept. Anytime you're left of it now, you can press enter. It'll put a boundary marker up there. Now get right of it. We are now right of the x-intercept. Press enter, and you can make a guess somewhere near there and press enter a third time, and it tells us the second solution is 4. So what we now want to do, it asks us to verify. Verify your solutions and state the answers. So let's verify when x is 2 and x is 4. We plug them back into our original equation. 0 equals x squared minus 6x plus 8. So when x is 2, we substitute that in. We get that substitution. We find out that 0 does equal 0, works when x is 2. We do the same thing when x is 4. Substitute that value in for x. Everywhere in this equation, x squared minus 6x plus 8, we notice that also is true, 0 equals 0. Once I have verified my solutions, I can now state my answer. So the solutions are x equals 2 or x equals 4. So we solved that by graphing on our calculator. Let's try another one. Solve by graphing. 2x squared minus 8x minus 11 equals 0. We can solve that by graphing y equals 2x squared minus 8x minus 11, changing the equation into a function and finding the x-intercepts. So we go to our graphing calculators again, go back to your y equals screen. You can now clear the previous equation you had in there and type in the one we're now looking for. Y equals 2x squared minus 8x minus 11. Again, we're going to go zoom 6, our standard viewing window, and hopefully our x-intercepts will show up. Great, they do. So we're looking for these two x-intercepts. How do we find those? We go second function, calculate. Number 2 is the 0. And again, we're looking for the left boundary, so something left of this first x-intercept. Now I can use my arrow keys and scroll till I get there. I see my cursor coming up. Or I can just pick an x value that's left. Any x value that's left of this, I can pick any number I want. So I could type into my calculator -4. -4 is definitely left of that first x-intercept. And I can press enter. And notice it puts the corresponding boundary marker up there. It now wants a right boundary. So anything right of that, looks like 0 might be right of that. So I'm going to type in 0 for x. And that puts up my left boundary. And now if I press enter again, or I can scroll near that guess, I find out that x, the 0 is -1.082207. All right, so let's make a note of that back in our slide. X equals -1.082207. 1.082207. And this is an approximation, all right? Not an exact value. So we found one x-intercept. Let's find our other x-intercept. We second calculate the 0. Get left of that 0. Well, it looks like I could pick the number 1, 2, or 3. Any of those would work. So I'm going to type in 1 for x. I want to get right now, so I'm going to type in any number to the right of that x-intercept. So maybe 8. And now it's going to find the x-intercept between 1 and 8. That's what we want. Positive 5.082207. So let's record this x-intercept as well. X equals approximately 5.082207. Now the next step we're asked to do is verify if these work, and then write our solution. So let's verify these. Again, we can verify these in the graphing calculator. So let's do that. So I want to go back to my home screen. So we go second quit. On my home screen, I want to type in the equation 2x squared. But for x, I'm going to put my first x-intercept, -1.082207, all squared, minus 8 times -1.082207, minus 11. And if this is close, we should get this to equal 0. That number is very close to 0. 2.727058 times 10 to the -4. All right, so we typed in an approximation. We got approximately 0. Let's try the next one. We won't go to as many decimals this time. So for the second one, let's just go 2 times 5.1, 5.08. We'll go 5.08, all squared, minus 8 times 5.08, minus 11. And again, this should give us approximately 0. And again, that's close enough for our purposes. That's pretty close to verifying these solutions are true. So we've now verified that these are true. It's probably not a bad idea to draw a quick sketch. All right, we draw a sketch of our parabola. We know it looks something like this. Label the x-intercepts. This is approximately -1.08. This is approximately 5.08. And we should state the window setting we used. X The X window setting is negative 10 to 10 by a scale of 1. The Y window setting is negative 10 to 10 by a scale of 1. That's our standard viewing window. We should also label the function y equals 2x squared minus 8x minus 11. That's the function we graphed, and we found the corresponding x-intercepts as our solutions. All right, so our solution should be x equals negative 1.08 approximately, or x equals approximately 5.08. And we'll go to the decimal point that the question asks us to. All right. Excellent. So let's just have a quick look at, all right, so let's just look at the roots of a quadratic equation. There are three possible outcomes when solving a quadratic equation. We can have two distinct and real roots, as indicated by this graph. We could have two equal and real roots, as indicated by this graph, where the vertex is on the x-axis, has one x-intercept. Or we could have no real roots, where the graph never touches the x-axis. Then there are no solutions to the corresponding quadratic equation. All right. So solve these by graphing real quickly. All right, so if we go back to our graphing calculator and go to our y equals screen, type in our new equation, negative 3x squared plus 8x minus 9, and go zoom 6, our standard viewing window, we'll see our parabola appear. Now, this parabola never touches the x-axis, so what would we say? We'd say there are no real roots, no x-intercept. So because this graph of the function doesn't cross the x-axis, we would say there are no real roots. All right, let's solve the next one. All right, back to our graphing calculator. Go to our y equals screen, type in our new equation, 25x squared, add 30x plus 9. Again, if we go zoom 6, our standard viewing window, the x-intercepts should show up. If it's not real clear, you can hit zoom and zoom in menu 2 there. It's going to zoom in on the coordinate 0, 0, which is the origin, and maybe we can see that the x-intercepts a little closer. So second, calculate the 0. So we're looking for this x-intercept. Again, left of that, maybe negative 1 is left of that. And it looks like positive 0 is right of that. Make a guess, and we're good. And that x-intercept is negative 0.6. So we can state the solutions to this equation are x equals negative 0.6. That's the only one that works. Verify it on your calculator. Make sure that's true. That is a good solution. All right. Finally, let's solve this one by graphing. So back to our graphing calculator, we go to the y equals screen, clear this equation, and start with our new one. Negative 3x squared, add 8x, add 4. If you hit graph, our viewing window has changed. Remember, we zoomed in? So now we can see both x-intercepts, so make sure you go zoom 6, and then you'll be able to see both x-intercepts. All right, let's find those x-intercepts. Second, calculate the 0. Get left of it. Again, I can use my cursor. I'll get left of it. That's fine. I can use my cursor to get right of it. There, my cursor is now right of it. And make a guess, I can just press enter. So one of my solutions is negative 0.43. And we find the other x-intercept. Second, calculate the 0. Get left of it. And get right of it. I'm going to pick a number right of that, maybe 6. And make a guess. There's my solution, 3.97. So back to our notes, we know that the solutions to this equation are x is approximately negative 0.43 and about 3.097. Excellent. So here's your assignment. We can work on that in class next day. Till then, bye-bye.